Video 5, Law of Cosines. Yeah, we're back for more, right? Law of Sines, last video. We're doing Law of Cosines. Law of Sines wasn't terrible, right? It wasn't too bad. Get ready for the Law of Cosines because it's not crazy tough, but it's definitely tougher than Law of Sines. All right, so when do we use the Law of Cosines? Well, basically when we can't use the Law of Sines. So I'll be upfront and honest with you. Law of Sines is going to be a lot easier to use than the Law of Cosines in most cases. Okay, so if you absolutely cannot use the law of sines, you're going to have to use law of cosines. All right. Now think about scenarios in which we could not use the law of sines. For example, what if I gave you all three sides of a triangle and I said, hey, this is 8, this is 7, and this is 5. Well, we wouldn't know a side angle combination because we wouldn't know what angle A is to use with side A, we wouldn't know what angle B is to use with side B, and we wouldn't know what angle C is to use with side C. So there's a situation where we can't use the law of sines. There's also another scenario, and I'll tell you right here. So situation number 1, if I give you all three sides, you can't use the law of sines. If I give you a side angle side situation, which we've talked about in this chapter, so if like if I said this was 10, this was 50 degrees, and this is 12. Okay, I can find the area of that triangle based on those three numbers, but what if I wanted to figure out other sides and angles? Well, if I wanted to use law of sines, I would know side C but not know side or angle C. I know angle A but I don't know side A, and I know side B but I don't know angle B. So there's not a side angle combination of one letter that I would know. So I would have to use the law of cosines. Now, you might look at this and go, holy crap, the law of cosines is 3 things? Well, the law of cosines can be written in 3 different ways, and it really depends on what thing you want to solve for. Now, if you look at this, hey, this first part kind of looks like the Pythagorean theorem, right? Especially this third one, a squared plus b squared equals c squared, but there's all this minus action going on after it. The one thing that's unique about these 3 things is really the angle. Angle A versus angle B versus angle C, because all the rest of the 3 versions use side A's, side B's, and side C's in some degree, right? So it's really the very ending part here. It depends on which angle you want to solve for, or that you could use, depends on which version of the law of cosines you would use. All right, so you've already got these written down in your notes. So let's try to apply one here. Okay, I'm not going to do a proof for why the law of cosines works the way it does. It's definitely more advanced and in-depth, and it would just take too long and probably confuse many of you. But if you want to look up the proof for the law of cosines, knock yourself out. It is not the most fun thing in the world to examine. All right, so first problem, I have a word problem. I need a triangle, and I need to call it DEF. So let's get a triangle. Let's call it DEF. DEF. Angle E, 64 degrees. Side D, which would be opposite angle D, this is 12. Side F, which would be opposite angle F, this is 15. And I just want to know, what is side E down here? So notice I gave you a side angle side situation, which I said law of cosines must be used here. So let's throw that up there. Let's get some more space over here. Now, the law of cosines, you'll go, hey, but you gave us nothing but A, B's, and C's. And now in this problem, you're giving us D, E's, and F's. That's not fair. Well, don't you think you could figure out what A, B, and C is if you were just using D, E's, and F's? Sure, right? I mean, what if we called this angle A, this B, this C, this would be side C, this would be side B, this would be side A, okay? So if we do that every time, if we apply it always to be, in terms of A, B, and C instead of other letters, we can do that. Now, which version do we pick? Do we pick the first, the second, or the third one? And again, I told you it depends on which angle you know or you want to know. In this case, we knew angle E, which is like our B here, which means if I jump back, I'm going to be using this second version of the law of cosines. So it's B squared equals A squared plus C squared. B squared equals A squared plus C squared. And then what you're going to notice, it's always a minus 2, depending on, doesn't matter which version we pick here. And then it's always going to be times whatever these 2 letters are that come after the equal sign. but no squareds this time, and it's all multiplication. Minus 2 times a times c times the cosine of. The angle that we're going to talk about here is always the angle that represents the opposite side of the very first part. So since we talked about b squared here, we're talking angle b there. Let's plug in now everything into this bad boy. Side b is really our e. So I'm going to adjust it and say we're really having e squared here. A squared, well, that's like our 12. That was like side D. So 12 squared plus c squared, that was our 15 over here, minus 2 times 12 again, times 15, times the cosine of angle B, which was really angle E, and surprise, 64. Now, this is the kind of law of cosines where you're going to be hoping you see all the time. Because notice, everything over here to the right of the equal sign is all numerical, right? That's all just one number. Could we plug that all into the calculator and get an answer? Yeah, let's do that. So let's figure out what is all of this as a singular number. So 12 squared plus 15 squared minus 2 times 12 times 15 times cosine 64 is approximately 211.19 if I were to go to 2 decimal places. Now that is e squared. So if I'm going to get e, I got a square root. So e is approximately the square root of 211.19. 14.5, and let's just say I go to 1 decimal point at this time. E is about 14 and a half, okay? Or it's 14.53, however many decimal places you want to go to, but at least do 1. There's the length of E. Now you might go, well, that wasn't too bad. Why were you saying earlier the law of cosines is tricky? The law of cosines gets tricky when this is what you're solving for, the angle. Because you got to be able to get rid of all this stuff, move it over to the other side, and then how do we get rid of cosine? Inverse cosine. So you're going to have a lot of stuff to do, and that's where people make some mathematical mistakes, some algebraic mistakes. All right, example 2. Let's look at an example where I give you, say, all 3 sides of the triangle. And you'll see now how maybe things will be a little bit tougher. So first we need a picture. We need triangle XYZ. So grab any triangle we want. I don't care if it looks equilateral, doesn't matter. But let's label X, Y, Z. Now, again, if you want to kind of play with it, you can go, well, instead of X, Y, Z, what if we pretend it's A, B, and C? That's fine. Then side X is really side A, side Y is really side B, side Z is really like side C. If you want to do it that way, go for it, okay? So I'll leave that up there. So side X would be opposite angle X. This is 13. Side Y, opposite angle Y is 8. Side Z, opposite angle Z, would be 9. And I want to figure out what is angle Y, which is this guy right here. And that's really like saying, hey, what's angle B? So, which version now of the law of cosines, let's shrink him up, move him over just a smidge. Oh, of course, that was all not connected. Scoot him over. So if I want to know what angle B is, then that means if I jump back, I'm probably going to want to use, again, this second version of the law of cosines because it uses angle B. So let's put it into action. So that was the b squared. Come on, let me write. B squared. Come on, let me write. B squared equals, oh man, this thing's just going to be a pain, aren't you? Oh, yeah, I can already tell. I already tell it's going to be one of those days. Isn't the board? Isn't the board? It's going to be one of those days. It's going to be one of those days. All right, let's try this again now that I've restarted it. B squared equals a squared plus c squared minus 2ac times cosine b. So b, side b, well, I said that's really like y, right? So that's 8 squared. A squared was like our x, right? So that's 13 squared. Plus c squared, that was really like my z. So that's 9 squared. Minus 2 times whatever these two numbers were individually, 13 and 9, times cosine of b. Now, I could write b there, but what was I really solving for? Angle y. So I've got a bunch of stuff to figure out here. So let's do this, right? Let's go ahead and figure out this. This is 64. This is 169. 9 squared is 81. Minus, what's 2 times 13 times 9? Oh, geez, we can multiply all that out. Let's see. 2 times 13 times 9 is 234. Now, that's 234 times the cosine of angle y. Now, out of everything over here on the right, because this is where we have all of our stuff, right? Out of all of this, can I combine any of this? And this is where people run into some problems. People will go, yeah, we can combine all of those things, but the 234 is being multiplied with the cosine. So really, the only like terms we can combine would be the 169 and the 81. So 169 and 81 make exactly 250. So that's 250 minus 234 times cosine y. Again, you cannot subtract those and call that 16 cosine y because you have to do multiplication before you can do subtraction. So now, we want to try to get the y all by itself, so we're going to have to start moving some stuff over to the left. First thing we would have to move would be the 250. So let's subtract it over. So it's gone. So 64 minus 250 is negative 186. And that is equal to negative 234 times the cosine of y. Now, we want to get the y all by itself, but it's attached to a cosine, which is attached to a negative 234. Now, the negative 234 is being multiplied, so we can now divide it over. Now, negative 186 divided by negative 234, well, at least the negatives are going to chop off, right? I'm just going to leave this the way it is. And yes, that can simplify, but I really don't care. I'm not done with the problem yet. So if I were to erase now all the things that are really gone, right? We said the negatives cancel. All of this is really now canceled out. And so really I have cosine of y is equal to, oh, come on, thought I could detach all that. Detach. Can I get just that now? Thank you very much. The cosine of y is equal to this fraction, this 186 over 234. So now finally, if I want to get the y all by itself, I can get rid of the cosine by taking the inverse cosine of both sides. And so now the inverse cosine of 186 divided by 234 makes angle y approximately, and I'll do it to the nearest degree here, would be 37 degrees. So there is angle y. Now at this point, if I needed to figure out something else, I know a side angle combination. I know side y and angle y. So I could now use the law of sines, which might be a better option for figuring out, angle x or angle z, instead of using the law of cosines over again, because holy cow, that was a little bit of a workout, right? Okay, so now the last problem. This is where I'm going to throw the workout at you. I want to know how big angle B is, okay? And I gave you a side angle side situation here. So you're going to discover that whatever version of the law of cosines you think you should use here, you're going to have to do more than one problem to get angle B. Okay, and I'm going to leave it up to you guys. I'm going to see if you guys can figure out, I know this is brand new still, but I'm going to see if you guys can logically figure out kind of which combinations of which formulas you're going to have to use to solve for angle B. And I'll tell you right now, you won't be able to use a law of sines at the first part of this problem. Could you use a law of cosine or law of sines eventually? Maybe, but you definitely cannot use a law of sines at the beginning of this problem. So we'll talk about this tomorrow.